For small batch production under 10,000 units, manufacturers face a critical choice. 3D printing's zero mold costs but higher per part prices, or injection molding's steep tooling fees but pennies per unit. So, which is truly cheaper? Let's dive into the data with insights from LS Precision. 3D printing eliminates mold costs but has a fixed per part expense. Injection molding requires 8,005 Vosen plus 4 molds but offers ultra-low per unit costs at scale. For under 500 units, 3D printing often wins. Beyond 2,000, injection molding dominates. 3D printing delivers prototypes in days. Ideal for iterative design changes. Injection molding takes weeks for mold creation but produces thousands of parts hourly once ready. LS Precision helped an auto client save 30% by 3D printing 500 parts in 2 weeks, avoiding $20,000 in mold costs and a 4-week delay. For small batches, this agility is game-changing. For mid-volume runs, 500 to 5,000 units, LS Precision uses aluminum or 3D printed molds to slash costs. Combine 3D printing for prototyping with low-cost molds for production. 3D printing or injection molding for under 500 units. 3D printing. Can 3D printing be used for end-use parts? Yes, with industrial-grade materials. LS Precision's experts answer your top questions, helping you make informed decisions. 3D printing, less than 1,000 units. Injection molding, more than 10,000 units. Your optimal choice depends on volume, complexity, and timeline. Visit LS Precision for a free cost simulation and quote tailored to your project.